The continuation of 25 today is in standard form. Again, yesterday we did intercept form and we did vertex form. Today we're going to look at standard form. Now, this method always works if you have 3 points. Any 3 points. Remember yesterday, for intercept form, we needed 2 intercepts and a third point. For vertex form, we needed a vertex and a second point. Today, all we need is 3 points. It does not matter if those 3 points are the roots, if they are the vertex, if it's the y-intercept, if it's any random point. As long as you have 3 points. Now, before we even go into doing this, let's sketch it so we have an idea of what we're going to look for. So we have an idea when we get an answer, is it feasible? So on the left side, let's draw a quick sketch. So all we want to do is estimate where these points are located. So to estimate that, I'm going to say the first one is -1, 6. So I'm going to give myself reference points every 5. Again, I'm just drawing a sketch. Okay, I'm just simply sketching. So -1, 6 will be up here somewhere. 3, -2 will be down here. And finally, -3, 4 will be up here. So we have a general idea of this parabola already, just by those 3 points. What is your, or who wants to come up and take a guess maybe, or draw what they think it might look like? Just based on the 3 points, no other information at all. What do you say?
It's going to go down.
Why is it going to go down?
Because the points are like spreading apart.
Okay, fair enough. But why can't it look like this, Anthony? I understand what you're saying, but like I'm connecting 3 points like that, aren't I?
Is that possible?
That makes no.
It's definitely possible, guys. That is a hyperbola, actually, another shape.
The highest point is like all the way at the top. At like negative.
It's sporadic to say that.
Okay, we don't know if this is the highest point, but it is a point. So, Juliet, if Juliet's statement is correct, which she says that that's the highest point, then it could look like this.
It can't do that.
It could look like that, theoretically. Or, it could go through the 3 points and go a little bit higher.
Yeah, that's probably. The axis of symmetry, like how's that going to be?
Well, we don't know what asymmetry
That's
is.
the point. That's the point. The axis of symmetry.
Again, guys, all we know is this. There's 1 point, there's another point, and there's the third point. We don't know anything more than that. Now, Victoria made a good statement. We know already that it's not going to be the red shape, because it says, if a parabola, okay? And the red shape that I drew there is half of a hyperbola. So we're not even concerned with that right now. So the hyperbola would look like this, and the other half is over here when you draw it. But we're not working on that. We're working on parabolas. So we're going to have a parabola opening down or opening up for now. I don't want to sit here and draw shapes all day. So let's go through a method that can actually give us the answer right away. Okay? So in this problem, we've done already intercept and vertex form. So now we're on standard form. So everybody list standard form in your notes. If you don't know it by memory, make sure you look back at what standard form looks like. You should know what standard form is already.
X squared
Can I get a hand? Vanessa? Very good. Again, ax squared plus bx plus c. Again, this is standard form. This helps you when you have 3 random points. If you are given 2 intercepts and a third point, use intercept form. Don't use standard form. If you're given a vertex and another point, use vertex form. Don't use standard form. This is your last resort, really. It works every time, but it takes the most time to do it, actually. Again, this will work for any 3 points, but it takes a lot more than intercept form or vertex form does. Now, I have 3 points right now. That's all I've got. I see 1, 2, 3 points. So, what can I do with my 3 points? Good, plug them in. So, Vicky, using -1, 6, tell me what the line should look like right now.
Plus B
Awesome. That's the first line. But you know what? How many things are missing right now? How many things do I need to know? A, B, and C. Which is how many? So how many equations do I really need? 3. Remember, algebra 1, I think you guys solved 2 by 2 equations, right? 2 variables, 2 unknowns with substitution method and elimination method. This is 3 by 3, so it's going to be a little bit trickier. And we're actually, concepts 26 through 30 is all about substituting, eliminating, and looking at major equations like 3 by 3s and 4 by 4s. Okay, so we're going to get to this topic, and this leads us right into it, actually. Today I'm going to show you a short version of how to get the answer. What would the second one look like? Who can tell me that? Eric?
Wouldn't it be -2 equals a parentheses 3 squared plus b parentheses 3.
Good job, Eric. And the last one? The last one? Juliet?
4 equals a parentheses -3 squared.
Oops, that's 3.
-3 squared plus b, -3 plus c.
Okay. So we can tell that we have 3 variables and 3 equations. Again, we've not learned, unless you guys might have seen this already in Algebra 1, it's possible. But to solve this by hand is not difficult, but it takes a lot of steps right now. So what I'm going to show you is the following. If we set this up and use our matrix on our calculator, it solves it in about a millisecond for you. Okay, it goes right to the answer. Now, once we get to concepts 26 through 30, we're going to go over how you solve this by hand and what the calculator is actually doing, which is very interesting, actually, to wonder. There's a class when you go to college, if you major in math or science or engineering, you're going to take called linear algebra. And linear algebra starts with the idea of matrices. And then when you go on from that, if you go on to calculus, if you look into calculus level like 3, where they do 3-dimensional stuff, like x, y, and z, you also use stuff with matrices. And generally speaking, matrices can describe any motion. So certain matrices represent a rotation of a body, another one can represent a translation of a body, another one can represent a translation up and down, a dilation. That's when you have like a scalar. So today what we're going to do is we're going to look and see how we can write this as a matrix and just use our calculator for now to get the answer. Okay, but we're going to go over how this works and where it all comes from in our next section. So I've got 3 variables and 3 equations. Here's what I want to do. I want to write them in a simplified form. So like I don't want 3 squared here. I want it to be a 9. I want that to be 9. And that just put the -3 in front. So just simplify everything and make it look a little bit nicer. So the one thing I'm going to do is I'm going to take all my constants and I'm going to move them all the way over here. I'm not going to subtract or add or anything, but I'm just going to put the equal sign over here. I'm going to just switch these 2 around. Okay? It is traditional to have all of your variables on the left side and your constant column all the way on the right side. So I'm just going to write it like this. So the first line, instead of -1 squared, -1 squared is just 1. So this just becomes a right here. Again, this right here, -1 squared is 1, so that's just an a. So I have a minus b, because it's a -1 times b, plus c equals 6. So I'm literally just flip-flopping the order in which I wrote them originally and simplifying all of my exponents. 3 squared is 9, so this becomes 9a. This is going to be plus 3b plus c equals -2. And the last line will also be 9a, but it's going to be minus 3b plus c equals 4. Okay? Again, this is the first line rewritten, this is the second line rewritten, this is the third line rewritten down here. Okay, I've just simply taken the 3 lines above and rewrote them all. Now, in matrix form, the way we write this is with big brackets. So start by putting big brackets on the sides. And what you're going to try and do is just list all of the coefficients in each spot. So what's the coefficient of this a in the beginning?
1.
This one?
1. -1.
This one?
1.
1. Coefficient, again, the coefficient, not the variable. And finally? 6. So I'm literally just taking all the coefficients on this side and listing them, and I'm simply putting the constants, which is the right-hand side, as the constant column, or we call this a vector. But again, we'll just for now call this a constant column. Next, we're going to have 9, 3, 1, -2. Again, here's the 9, here's the 3. There's really a 1 here in front of the c, and a -2 at the end. And the last one, 9, -3, 1, and 4. Now, a little word or a little note you might want to write down on the side. If you have two rows that are identical, it doesn't work. Again, if somehow you got two rows, see how these rows, this is row 1 here, that's row 1, that's row 2, and that's row 3. If any of these two rows are identical, it means you've used the same point twice, actually. So, for example, if we go back to the beginning and look at our points, if by accident you use 3, -2 two times, again, by accident you use that twice, it's not going to work. You're going to get an answer that's indeterminate, or it's just going to say there's going to be error in your calculator. Okay? Because you need 3 equations that are all different to solve for 3 variables. If this row was the same as this row, then these equations would not be different. They would be the same equation. Okay, so again, we're looking at 3 equations here. Questions so far? Okay, I know this is a little bit new to you in that sense because we haven't seen this. Now, I'm putting a dashed line here just in my mind to know that these are all of my coefficients. And these are my constants. And that's always going to be the setup that we're going to have. Again, your coefficients as the first part and your constant as the end column. So whatever your whole numbers are at the end here, and they don't have to be whole numbers, I'm sorry, but whatever your numbers are without a variable term on the end here. At this point in time, we can actually just go right into our calculator to solve this. Okay, so take out your calculator, turn it on. It's going to take us about 5 minutes just to go through all the steps. But once you've done this once or twice, it's actually very simple to go through it. But you have to practice this one or you're not going to get better at it.
Don't mess us up this time.
It'll mess you up.
Last time you were like, press second, catalog, and me and Andrew did the exact same thing, and we messed up.
It's not my fault you messed up.
You told us to press second.
Yeah, of course. Second, and then catalog. That's the open the catalog.
No, you said.
No.
Dang it, I just did that. You told us the wrong button though.
I don't know what you're talking about, John.
Oh, man, we have the recording.
All right, you find it.
Well,
Let me know.
get you.
Now, we're not using a program today. Okay, it's not a program. It's a function that's already embedded into your calculator. And as you can see, do you see the word matrix anywhere?
Yeah, okay.
Okay, right over x to the -1. So press second, and then see the x to the -1. It says matrix. Press that.
We're entering the matrix.
And most people probably have nothing on here, and you probably don't if you've never used it before. So this might be empty, and it doesn't matter if it's empty or if it says anything. It makes no difference. Here's what we want to do. Again, you're pressing second, and then the x to the -1, which is a little matrix word above it. And it should look like this. Everybody go over to edit, because we want to edit one of our matrices. So go over to edit, and hit enter on A. Okay, hit enter on A. Mine are floating. Hold on, let me just turn the mode off so it doesn't confuse anybody. I put it on a circle. I need to put it on floating, rather. Okay, just to make it look better. I had all those decimals because I changed my settings. Now,
What if you have?
what we want to do is input a matrix. I'm sorry?
What if you have stuff there?
If you have stuff there already, don't worry, because you can type right over it. Okay? Let's go back to our actual problem and take a look. How many rows do I have?
3,
How many columns?
4.
So it's a 3 by 4. Again, the dimensions of a matrix are always rows by columns. Okay? Again, the dimensions of a matrix are the amount of rows by the amount of columns. This is something that you have got to memorize, because you're going to use it later on this year. And if you study calculus and any other subjects in math, you will use matrices over and over again. Okay? Rows and then columns. And it's a little bit, you don't want to use the whole like alphabetical trick because it's the opposite there, right? You know how like a lot of teachers are like X and Y, X comes first and Y in the alphabet? R and C doesn't work that way, unfortunately, okay? So again, rows by columns. Let's go back in here. So we have a 3 by 4. If yours doesn't say 3 by 4, here's what you do. When it's highlighting over that value, press 3, enter. It'll go over to here, and then press 4, enter. Mine happened to be a 3 by 4 already because I was using this the other day. But you don't, it doesn't have to look like that. Again, once you press 3 by 4, you're going to see now, you're going to see only 9 spots. The other column is off the page. So once you go beyond 4 columns, you'll see these dash marks here, which means you can keep going to the right. And you'll see if you keep pressing to the right, you'll see another column there. So if you had 7 columns, you're going to see in a bunch of additional columns here. You got to keep just going over. Okay? So at this point in time, all we want to do is enter the coefficients the exact way we see them. Okay, so back to the original page. I've got 1, -1, 1, 6. So 1, now make sure you use the negative symbol down here, not the minus sign. 1, -1, then a 1 again, and then finally a 6. And every time you input something, just press enter afterward. So 1, enter, -1, enter, 1, enter, 6, enter. And just continue the rest of the way.
When you finish entering them all, you press back.
When you finish with them all, pause for a second, we'll go through it. It's not a graph, actually. 9, 3, 1, -2. Yeah.
When do you want to know about determinants?
We will, when we get to that topic, though.
It's gonna be like this one.
Yeah, but we definitely will. And the last one, thank you, Jay. 9, -3, 1, 4. Okay, now everything's been input into my matrix. So at this point in time, quit out of here. Press second and then press quit. Press second and then press quit. And you have to quit out. If you don't quit out and you do the next command without quitting, it will input the next command into the matrix. You don't want to do that. What you want to do is you want to reference the matrix with another command. So again, if I left the matrix open and I tried to do the next thing, it would put that command into one of my spots in the matrix, which is not what I want to do. What I want to do is the following next. I got to go back into matrix, so second matrix. Go over to math now. Okay? Go over to math. We're not going to use it for this one. I'm going to show you another way to do it. Go over to math. Go down to RREF. It should be letter B. It's letter B on mine, actually. I don't know if it's the same. It might be. Not ref, but RREF. If you want to write this down, we're going to talk about what this means when we get to concepts 28 and 29, but if you want to write it down, this means row, reduced. This word is echelon. ECHELON, form. And I'll show you what that means in a second. It's actually, it's fancy words, row, reduced, echelon, form, but it's actually quite simple, and you're going to see it when you see the answer. Press enter. It'll bring that up on your home screen. And then we want to do the row, reduced, echelon form of the matrix that we just input. So wherever you input that matrix, go back to second matrix. We input into A. So if you input into B, you got to go down and hit enter. But we input into A. So just hit enter. Again, we're not editing anymore.
Wait.
We're under names.
Mine didn't pop up on the screen.
Because you did exactly, okay. Let me use John as an example, sorry. He did not quit out of the matrix before he did RREF. So his calculator is attempting to put RREF into his matrix. And that doesn't work. So go back and leave this as a 1. Now we quit out, now try. Second matrix, now do RREF, it'll bring it on the home page. Press enter, close your parentheses, and then press enter. I'm going to discuss what this means. Some of you already know what this means already just by looking. If we think about this, in our original matrix, each of these positions represented one of the variables. And if we go back here, the A was represented by the 1 here. The negative B was the negative 1. The C was the 1, and the 6 was the 6. So looking at the matrix here, again, looking at this matrix right here, we can actually go back and write the equations also. You see how we wrote the matrix from the equations? We could also take the matrix here and go back this way, just by looking at the coefficients. So this tells me there's 9 A's in this equation. There are 3 B's in this equation. There's a C, and this whole thing equals -2. Well, that's this line right here. Again, this you can go in the reverse direction. So what I want you guys to do is think about what this means now. Try and write 3 equations from what you have on the board right now. Again, going backwards. Think about all these positions and what each position means and what each row means. You can use this as a template, but I want you to try and figure out how this gives us the answer on your own. Some of you might know already, but please don't call it out. Just try and figure it out. Again, go from the matrix that's on the board back to the equations, or back to an equation representation of this matrix. Use the last one as your example if you need to, the one that we used to actually input into the matrix here. If you think you got it, just raise your hand. I'll come over and take a look. Very good, Jay. Absolutely. That's the first person to get it. Jason got it right away. Nobody else? Okay. Think about how we went from this, okay, where these three moved on to this, right? So if you go backwards, then you get these three equations right here. Like this being 1a, negative 1b, 1c, and 6. That's that line right there, right? So take this and go backwards. Try and write the equations. Again, you are attempting to write the three equations that are represented by this matrix. That's what you're trying to do right now. Write the three equations, or the three rows that are represented by that matrix. What was the constant column on our matrix? It was the C.
Yeah, that equals 0.5 negative. The other one's 0. I can explain.
I'll get an extra hand and I'll put it up high. Where did that A come from?
I know who's on it.
So that's just one A. So you have
No, there's no.
this space right here is like the equal sign.
That's why I was like, all that was sign.
Yeah, it's really easy.
Okay, most of you got it already. Let's take a look. That means your matrix input was not correct. Look at the.
Oh, why don't you do us?
I think she has that guy.
She needs second half. Oh, second.
No, I can tell you right away that there's something wrong with it. Just by looking at the answers here.
Just look at it.
Yeah. Just be 9, negative 3, 1 in the last column. That's right. Remember I said if you have the same row twice, it's not going to work? Look at your second row, look at your third row. Is there any negative bar in color? 9, then negative 3. Yeah, third row. I know. All right, so we can simply do the following. Everybody, go ahead and do this. Just put an A here, a B here, a C here. And take a look. So this says the following. You can't write on your calculator. Sorry. This says 1A plus 0B plus 0C equals negative 0.5. So does the B and C matter?
No.
So this first line just tells me that A equals negative 0.5. The second line says there are no A's in this line. There's one B. There's no C's, and that 1B is equivalent to negative 1. And finally, the last line, C equals 5.5. Again, whenever you see a 0, it means that there are none of those variables there. There are no A's, there are no B's, there's a C here, and that C is equivalent to 5.5. So these numbers are A, B, and C in order. Okay? As long as this is the A column, this is the B column, and this is the C column, this will always be A, this will always be B, and this will always be C. Now, quickly, I want to show you guys what happens if you type in the wrong thing so you can see in the future in case you do this. So if, for example, in your matrix, sorry, Anna. So
But that's
hers
spot today.
was, instead of a -3, she had a 3 there. Okay, no big deal. She put a 3 in. So what? We're going to go and do the row reduced echelon. Everybody see how I pulled the same command, by the way, or no?
Yeah.
How do you do it?
Second on,
Second
enter.
on.
Very good. If you want to bring up the same command as the last line you did, press second enter, and it brings up the last entry. So again, if I press second and then enter, it brings up the last, whoa, oh. Okay, now that I've cleared it, it's going to the one that I did before that, which was the quadratic formula from yesterday. So now I got to actually go back and do it. It's letter B, right? Okay. Now, notice what happens here. We want to get 1, 1, and 1, right, in the diagonals. Look at my diagonals from the last time. See these diagonals are all 1s here? And see everything else is a 0, 0, 0, 0, 0, 0? All those zeros are indicating that there are no B's, no C's, or no A's in certain spots. Now, if I look here, I've got the 1 here, I've got the 1 here, but this says 1A plus 0B plus 0.3C equals some number. These are not going to give me answers here. Okay, it's an indeterminate matrix, or it's a matrix that does not give me an actual solution. So if I were to write these out and actually look at them, and I wanted to go over to see my answer, I can keep pressing to the right. And look at my constant column at the end. It's 0, 0, 1. So let's write this out just to see what it looks like. So I've got 0, 0, 1. And I've got 1A, no B's, plus 0.3C. That's the first line. The second line, I've got a B in the middle here. That's that B. And I've got negative 2/3, or we'll say 0.6 negative C. And the last line, what does the last line say, guys?
0.
0 plus 0 plus 0 equals?
1.
Does that make sense? Can 0 equal 1? It's a contradiction. Based on that alone, you know right away this is not possible. And initially, it looks like, okay, we got 2 different variables here. It kind of looks like it could work. But that last line alone tells you right away that there's no possible way. Okay? So when you get an answer for a row-reduced echelon form matrix, you have to have 1s in the diagonals. And we call those pivots. If you'd like to write that down, please. You need 1s in the pivots. The pivots are the diagonals coming down from upper left to lower right. Again, all of these values are called your pivots. If they don't have 1s in them, then either there's a mistake or the problem cannot be solved. Pivot, P-I-V-O-T. Sorry, P-I-V-O-T.
Oh, pivot, like
Like pivot foot in basketball, where you pivot around, same word.
or baseball. I know.
Literally baseball you do, on bases. You can't lead, so you do have a pivot. And pitching you do, actually, yeah.
I don't even know anything about baseball.
Alright.
I just said that.
Now, that was the first problem. Try the second one on your own, please.
Yeah.
Okay, I'll blow this up a little bit so you can see a little bit better. Again, use your matrix method. If you don't have a matrix calculator or a calculator right now and you want to still do your homework, which you should, tonight I'm going to post a link to an online matrix calculator. And you know what? While you're copy this down, get your points. In about 3 minutes, I'll pull it up here so you can see how to use it. There are an infinite, not literally, but an infinite amount of online matrix calculators. People make them all the time, and they're very easy to make, actually. So you'll see, if you just type in matrix calculator in Google, you'll find one that does it for you. And it has REF and everything. So if you don't have a graphic calculator right now, you can still try it for your homework.
You made an application for Android.
You can make there probably is an app on your Android or iPhone if you have that too, actually.
You made it when you was a little kid. You just want to tell us.
I didn't.
He created that.
You made it.
Again, I want you to write down the 3 points that you're given here, guys. I'm going to switch off this in about 30 seconds, so write down the points you need, please. And it's clear the first 2 points, one of them you have to estimate, but it's obviously 0 for x. You can see it's on the y-axis there.
Which would be 3 in the middle?
Yeah, so here's -3 here, guys. Again, because you're between that and -4 and -2. I know that one is not as obvious. I mean, you don't have to use those 3 points, though. Does everybody understand that?
Yeah.
I mean, in this case, actually, let's see. There's nothing any better though. Like this one is a little bit off here. This one here is a little bit off.
Negative 5, negative 4. No, that's a little bit off.
Negative 5, negative 4, yeah, that's a little bit off also. They're all a little bit off, but this one is actually the y-intercept. I'm telling you it's negative 3, okay? You have to be given 3 points that go through your intersection of the grid lines. If you don't, then you need to estimate. But in this case, you have the 3 points. But just keep that in mind. If you don't have 3 points that it looks right away, make some estimations. And you can use decimals in the matrix. There's no problem with it. Okay, I'm going to pull up an online matrix calculator. I hope you have those 3 written down. See, look, I've even looked at 2 of them. Oh, you can't, it doesn't show on here. But I've used these 2 before, that's why they're purple on my screen. Are they purple from far away?
Yeah, you're kind of colorblind.
No. No, that's not a good one. I'm going to go back and use a different one.
It's only like 24.
There's a certain one I always use. Here it is.
Well, too complicated.
Okay, this one has a lot going on, but this would be where you'd input the matrix stuff right here. These are all your rows and stuff. And then here, see this part right here? If you drop this down, see REF? Okay, if you type in all your numbers and go, it'll display the answer. And there's a lot of other stuff you can do. I can
Ready?
Are you ready? A lot of this stuff is all used in engineering, I'm telling you now. Matrices are all over the place, okay? So all these different things you will use. But for now, we're just using RF. But we need to type in our equation. Then you do your homework after school here, instead of running around the hallways.
Mr. House, say swag. Come on, Mr. House, say it. Mr. House, say it.
I'll stop with first.
So,
Yeah, after Thursday when I have to.
Daniel, what project we
Yesterday.
project?
When I had a meeting here, you guys said.
I was walking right up. He
got real mad. Get out. Let's go, guys. You should have answers by now. Come on.
Wait, what?
I'm just phone thinker.
Most people haven't even written anything. Well, I mean, I have it written down. I'm going to check. That looks exactly right.
Thank you. Don't talk to me.
Yeah. Guys, when you have zeros, notice what happens to your problem right away. The C you get C automatically in the beginning. Anybody notice that, guy?
Yeah.
If you look at your first equation, you're going to have 0A plus 0B. I'm sorry, not the first one. From this, well, whatever order you put them in. When you plug in this equation into your standard form, you're going to see all the x's are going to drop off. And this is the y-intercept, so this is the value of C automatically. Let me go through that in case that's not clear. So here, we've got 0 equals A times negative 6 squared plus B times negative 6 plus C. Second line, negative 8 equals A by negative 2 squared plus B by negative 2 plus C. Question? Okay. Finally, we got negative 3 equals A times 0 squared plus B by 0 plus C. Look at the third equation, everybody. A and B drop off already. So you know the value of C. So for this setup, you can actually use a 2 by 3 matrix instead of a 3 by 4. Okay, pause for a second. I know a lot of you are still working on it. We have 2 minutes left. I want to show you this. You can finish the problem on your own with the 3 by 4, but I want to show you real quick. Look at this line here. These drop off. So C is just negative 3. Do we all see that? So start by writing C is negative 3 over here. Now, in these two first lines, just replace the C with a negative 3. So instead of this, just put in minus 3 and minus 3. Well, now when I write this, I only have two equations and only have two variables now. You don't really need, yeah, you can do this by hand with substitution or elimination method. But take the 3 and make sure you move it over here because it's a constant. It's got to go with the constants. So this is going to become a positive 3 equals 36a minus 6b. And this one is going to be, if I add 3, negative 5 equals 4a minus 2b. Well, if I write this as a matrix now, I got to move these on the other side. 36, negative 6, 3, 4, negative 2, negative 5. Now I only have a 2 by 2 matrix. Again, how did I do that? The third line didn't matter because these zeros were here. So this told us that C was negative 3. I then replaced C with negative 3 in the first two lines, moved those over, and that gave me these lines. And now it's two equations, two variables. It's a 2 by 3 matrix. Solve this one. And you can solve this by hand. Solve for A or solve for B and then substitute in. Or use elimination if you remember. Thank you, sir. Okay, again, quickly, let me go through this, and I'll do this one in the online matrix so you can see. 36, negative 6, 3. 36, tab, negative 6, tab, 3. That's how you can go through these quickly if you press the tab key. Next line, 4, negative 2, negative 5. 4, negative 2, negative 5. Now at this point, I have RF highlighted. If I didn't, I just go down and hit RF. Hit go under display, and down here at the bottom corner, you'll see that A is 3/4 and B is 4. And if you did it with the 3 by 4, you should have gotten the same answers. Again, this is now only a 2 by 3. You can always use the 3 by 4 though. Tonight for your homework, the back of that worksheet, or the rest of the problems, you're going to have 4, 5, 6, 7, 8, 9. Okay? You did 1 through 4 last night. 5, 6, 7, 8, and 9, please. I'll put this Nick on that line, yes. Yeah. During break? Today I am, yes. What do we need? My hand? I can show you, what lunch are you in today? You're in the second lunch, right? Check for me during break, I'll try to be available. Okay? Check up here or the workroom.